So onward with our program, the 5 core questions of asset management. We did an asset management roundtable at our Reliability 2.0 conference last April in Las Vegas. And we challenged Derek Burley, who I thought I saw in here earlier. Is he here? Derek? And Jeff Smith, who's he's working for somebody who's actually here at this conference, but he said he booked him doing assessments during the week of this conference. So he's not here, but we challenged them to take the 7 questions of RCM and see if we could apply those same 7 questions to asset management. And they did a pretty good job, and that work's continuing and developing, so don't take it, steal it, ask Derek and Jeff what they're doing with that, and see if you can contribute in some way, shape, or form. But while we were doing research into who was doing what in decision-making around asset management, we came across Tim Tabor, and we saw he had a pretty fully developed 5 core questions of asset management. So as we were putting this together, we absolutely wanted to make sure he was a big part of this this day that we're doing on asset management. And without any further ado, how about a warm welcome for Tim Tabor? Thank you for being here, Tim.
Thanks, Terry. So what I'm going to talk about today is what is asset management. And I had a colleague who would often describe it as a box. And he said, this box is full of stuff, and you've heard a lot of stuff today that it's full of. And I like to say this box is full of TLAs. Do you guys know what TLAs are? 3-letter acronyms, right? RCM, PDM, PMO. All that stuff is components of asset management. It's in this box. And then he'd like to say, well, this box has 6 different sides, and there's a different way to look at it depending on which side of this box you're looking at. So I think today you've seen a couple sides of the box, and what I'd like to do is turn the box a new way and talk about it a little bit differently, and what I call the 5 core questions of asset management. And these aren't my questions. The Environmental Protection Agency uses these when they train municipalities to help understand asset management. This is one of the tools they have. So the 5 core questions are, what is the current state of your assets? What are your defined levels of service? Which assets are critical to providing those services? What's your best operation and maintenance and capital improvement strategies? And then what is the long-term funding strategy? And what we're going to do is delve into each one of these 5 questions a little bit more, but generally the idea behind these questions is if you start addressing them, and if you can fully address all 5 of them, it generally demonstrates that you have very good asset management practices in your organization. So I guess before I get into it, let me give you a little background on myself because I know absolutely nobody here. I'm here till Friday, so I hope I get to meet many of you. But I'm a civil engineer, and I graduated from University of Buffalo. I have a master's in engineering management. And early on in my career, I was working on a project at a large wastewater treatment plant. I was doing some design work. Right in the middle of that project, or actually early in that project, this large wastewater treatment plant, which was on the Hudson River, just north of New York City, treated 150 million gallons a day, and had terrible asset management practices, had some equipment fail. They didn't do good maintenance. They had a catastrophic failure on several pumps, and they could not provide treatment of the wastewater. They didn't have spare parts, so these pumps were down for a long period of time. So the result of that was untreated wastewater was being discharged into the Hudson, 150 million gallons a day. It was July. They decided not to notify anyone because they were embarrassed. You know, let's get it fixed. You know, let's fix it, then we'll tell people. Well, people got sick downstream. Untreated wastewater, beaches did not get closed, and it ended up being a big event. And the New York State Department of Environmental Conservation stepped in. They put the chief operator of that facility in prison for negligence. They mandated that treatment plant, and I'm not going to name names, but the county that owned that treatment plant implement better asset management practices. So I pretty much got thrown into the deep end to figure that out. At that time, we implemented a CMMS program. We developed some things. But since that time, that was 1997, all that I've been doing with my career is helping organizations find better ways to manage assets. whether it's implementing CMMS or doing high-level strategic planning. That's all I've been doing. So I tell you that story because a majority of my background is in the water, wastewater world. I've done transportation, I've done railway, I've done manufacturing. But a lot of the slides and a lot of the examples that I'm going to show today come from that world. So what is asset management? So a couple basic concepts. Infrastructure, assets are the foundation to sustaining the quality of life. Impacts of failures can be severe. And what asset management is looking to do is make better decisions on the entire life cycle of that asset. And that's kind of alluding to everything you've heard today: the design, planning, funding, acquisition, construction of assets, operation, maintenance. So you can see this is one component. Obviously, everyone here is very focused on that: the renewal and replacement of assets. You're looking to do that in the lowest cost of ownership. Okay, so let's get into these 5 questions. So the first question asks, what is the current state of your assets? And really, to understand that, you have to know, what do you own? Where are those assets located? What condition are they in? How much life do you expect out of them? What's its remaining economic value? And again, most of my clients are municipalities. So if we were to look at any town USA, there's assets, infrastructure all over it. This is any town USA. We have roads, we have bridges, we have buried infrastructure, we have water distribution, wastewater collection, wastewater treatment plants. These are all assets. And these assets don't just exist to exist. They exist to provide a service to the residents of this community. So let's delve in a little further. You have a wastewater treatment plant. A wastewater treatment plant is made up of lots of assets. We have blowers, motors, piping, valves. We have complicated electronic and control systems. We have facilities, buildings, grounds, sites, roofs, and process equipment, very expensive, complicated process equipment. These are all assets. So the first question is, do you really know what you own? Do you know when it was installed, how much it cost, how much it's going to cost to replace? What about rehabilitating it? Do you know when it should be rehabilitated? So that first question is, do you really have an inventory of your assets? Have you gone out and looked at your assets? Now, in the private industry, this question is pretty easy. Most organizations do. In the public sector, municipalities, this question, oftentimes an organization or a municipality doesn't know what they own. Do you have an electronic inventory? There's obviously many different software vendors out there that will sell you a CMMS system to keep an inventory of your assets. A simple system, a more complex system. Do you have them organized in hierarchies where you're not only breaking down to individual assets, but you have your asset systems identified, et cetera. So do you know what you own? And of course, when you do that, you might come across assets that are really deteriorating, really posing a risk to your organization and need to be dealt with right away. Let's delve into this question a little bit more. A couple truths about assets. Not all assets or asset systems are created equal. Assets will eventually fail. Failures directly affect the system performance. Failures are constrained by cost, and resources should be guided by the likelihood and consequence of failure. And we're going to spend more time talking about this because this is a key concept in asset management. The other concept is, do you understand how much life is left in your assets? So, this is your typical decay curve. And do you understand, is your asset currently here in its time frame, or down here, or is it back here? How much life do you have left in your asset? That's another key element of understanding this first question. Now this is really important, and that is talking about asset failures. And the definition that I use for an asset or an asset system failure is, a failure exists when the asset no longer provides the service you need it to provide. Now a lot of people instantly think of a mortality type failure. The asset failed, it broke, it's not functioning. The sewer collapsed, the bridge collapsed, the pump stopped. But if we think about an asset failing in that other context, that it no longer provides a service we need it to provide, there's actually a couple other ways that could happen. It could be a capacity issue. It doesn't have the capacity, or it can't provide the throughput that we're requiring from it. So it's failing us. Maybe it's a level of service. It's a quality issue. It's not providing the quality of product we need. It's not providing the level of treatment that we need to meet some new regulation. It's too noisy. Mortality is the obvious one. And then the last one is efficiency. It's failing us financially. In other words, there's new technology out there that can do the job a lot cheaper, so our current assets are failing us because they're too expensive to operate. They require too much energy, too much chemicals, too much babysitting, something like that. So they're failing us financially. So first of all, we have to understand that an asset fails when it no longer provides the function we need it to provide. These are all the different ways that it could fail. Okay, the second question, and one of the most important, and one of the ones often skipped, asks, what's our required level of service? What services are we providing? That's if you're a utility. If you're manufacturing, what products do you produce? What regulations are you required to meet? What's your actual performance? What are your customers willing to pay for? What's the demand from your stakeholders? Okay, very important. So level of service is really understanding what your customer expectations are, defining level of service, what are the risks, and what are the costs. And it's really a balancing act of balancing the cost of those services versus expectations, risk, et cetera. And everyone here probably made a decision on level of service when they booked their travel to this trip. So how many people here flew down to this conference or took an airline, right? Now, how many people paid the extra money for first class? So you all chose that cheaper level of service of coach, or you got the free upgrade because you travel a lot. So that's a level of service. Another example of level of service is every time you go to fill up your car with gas, you're choosing a level of service, a quality choice. Are you putting 87 in, or are you putting 93 gas in? 93, more expensive, better quality product. So understanding your levels of service that you're trying to achieve should drive all the decisions of how you manage your assets. Okay, so that's the second question. Understanding and documenting. This is kind of your organizational mission statement. If you're a utility, it's the services you provide and the quality that you're desiring to provide to your customers. So here's an example of a wastewater industry, what the CERT levels of service that they desire to provide are. I'm not going to go through this in detail, but let me just highlight a couple of things. There's different categories that they chose. So they're going to have wastewater, conveyance, and treatment systems that are reliable. Okay, and then these are the details of what they define as reliable. They're going to meet all the regulatory compliance that they're met, whether it's EPA or New York State DEC or whatever regulatory agency that they're required to meet. They're going to be in 100% compliance with those. They're going to have assets that protect the public and employee health and safety. Okay, and some criteria that they evaluate, the effectiveness of that. They're going to be fiscally responsible and provide all these services in a way that they have the confidence of the public. Okay, so this is their desired levels of service of how they want to operate their utility. And why is it important to document these levels of service? Because then when you make decisions, it's no longer on a notion. You actually have documented quality or levels that you're trying to maintain your assets to. You can communicate these expectations to your stock, to your stakeholders, whether it's management, whether it's shareholders, whether it's residents, and you can hopefully try to make the case that an increased service is increased costs, and then what the trade-offs and risks are. Okay, so we're going to come back to risks here. And again, you can negotiate. If they want to cut budgets, you can demonstrate the risk, okay? If they want to impact rates, what's the long-term investment? Again, it's going to come back to the risk of not being able to provide those services or that quality of product or that capacity. Okay, so what was the first question? Does anybody remember? What's the state of your assets? What's the second question? Okay, here are like 30 different ways. But anyway, I think you're all right. What levels of service are you trying to provide? What quality of products? So with knowing those two items, you can come to this third question, which asks, which assets are crucial to sustain performance? And really that's understanding, how do assets fail? How can they fail? What's the likelihood of failure? What does it cost to repair? What are the consequences? These kind of sound like RCM a little bit, right? But anyway, this is all about risk. This is understanding the risk of your assets. What liability do those assets pose? So we have the two components, the two main components that we're looking at, which is what are the consequences if an asset or an asset system fails? What is the likelihood or probability of that occurring? And we take these two components and we determine the overall risk. Now here's just some ideas of things that could be a consequence. You could have production loss. If you're a utility, you could have property damage. You could have a high cost to repair. You could have potential safety issues, impacts to public image. You could have long duration of failures, number of affected properties, environmental impacts, triple bottom line. However you want to look at this, you have to identify what consequences you would have if an asset failed, and then you have to look at what likelihood you would have to failure. Okay, so risk is consequence multiplied by likelihood. Very simple formula. Now, here we have our desired levels of service, and that should be directly in line with your consequences. So when you evaluate the impact or consequence of an asset failure, you should directly line it up with what your desired levels of service are. Okay? So we have scoring criteria, and again, I'm not going to go through this, for both consequence of failure and likelihood of failure. Let's look at this in a little more detail. Our consequence of failure scoring criteria is directly in line with our desired levels of service. So what are the impacts to system reliability, regulatory compliance, public and employee health and safety, fiscal impacts, public confidence, okay? So our consequences of not meeting those documented levels of service. Line of sight to our organization mission. And then I'm not going to go into likelihood of failure or probability of failure, because maintenance reliability experts, this is pretty much what you do. You look at assets and try to figure out how likely they are to fail. What's the probability of failure? Okay, but some scoring criteria on that so that you have criteria, documented criteria that you can publish and put out there in front of your management and say, this is how we're determining risk. And then you get a risk matrix, right? So you have your likelihood of failure, in this case a 1 to 10 score, consequence of failure 1 to 10. And you go ahead and you evaluate your assets and you go ahead and score them. And this will be your risk number. Now, these risk matrices are kind of a big deal, okay? And most organizations that I do this with, when we finally get to this point and we map out the risk, it's kind of like an eye-opening moment. Okay, now this is all making sense. I'm looking at how likely are my assets to fail based on some documented scoring criteria, not just a notion. What are the consequences of those assets failing, directly in line with my desired levels of service? And those assets will generally fall into 4 different quadrants. Okay, so we have assets with a high consequence of failure, but a low likelihood of failure. Okay, that's interesting. So what are we going to do with those assets? Well, if they do fail, something significant, there's going to be a significant impact to our level of service, to our desired quality. So we want to do some aggressive monitoring of those assets. We definitely want to make sure our maintenance programs are paying attention to them. This is a good application of predictive maintenance, the cost justification. We have assets that have a low consequence, low likelihood of failure. Again, what's our management strategy for those types of assets? Run to failure, spare part management, etc. Assets with low consequence, high likelihood. Again, what's the best management approach for those? And of course, up here, the high-risk assets. High consequence of failure, high likelihood that they're going to fail. So how are we going to manage those assets? Again, we have all this documented and scored, so if people want to know why we scored something high, we have all the documentation behind us. Why is that showing as a risky asset? And that brings us to the 4th question. Okay, so let's review. Question 1 was, what's the current state of my assets? Question 2, level of service. What's our organization mission? Question 3, which assets are really critical to providing sustained services? And then question 4 is pretty much the rest of the conference, what you guys are going to focus on. What is your best strategy to deal with these assets? Okay, and the strategies are operation and maintenance, capital improvement, what alternatives exist, what's the most feasible for your organization. Okay, so this is really where the rubber hits the road. You have line of sight, you've identified which assets are critical, directly in line with your organization's level of service, mission statement, and you're trying to find what's your best strategic approach to dealing with those risks. Now, we have all sorts of risk reduction opportunities, and I don't see John here, but John said there was 42 in the Salvo project, and I thought that was great. Okay, so risk reduction. So the obvious ones, capital investment. We can rehabilitate assets, we can replace assets. Those are both reducing the likelihood of failure. They do nothing in reducing the consequence of an asset failing. Okay, we can add redundant assets. That's going to impact consequence. It has nothing to do with reducing the likelihood of existing assets failing. Those are all asset type strategies. Then we have O&M protocols. We can develop different SOPs, improve planned maintenance. We can enhance monitoring through SCADA, maybe predictive maintenance. We can manage our demand. We can improve emergency response, spare parts, or we can reduce the level of service with our shareholders. Okay, so if they're not going to give us money to do any of this or any of the other 40 things that John Woodhouse discussed on his slides, then we have to ask them, well, what changes to the level of service should we make, or what risk are you willing to take because you're not giving us the budget that we're saying we need? Okay, so that's where we're coming up with a strategy. Now, the strategy is not just maintenance. We have to look at the entire life cycle of an asset. And there's a couple different approaches when we establish a strategy. I often like to say a strategy is how often are you going to replace this asset, when are you going to rehabilitate or overhaul it, and then what maintenance are you going to do? And that, combined with a couple other concepts, really dictates the overall strategy we're going to apply to an asset. So we could do nothing, just let the asset run to failure, and then we're just going to replace it, high expense, and then just continue doing that. That's an appropriate strategy. We're going to really do nothing except overhaul it every few years or every year. That's an appropriate strategy. Or we're going to do some maintenance activity and then overhaul it every 3 years, and then plan on replacing it every 9th year, something like that. Those are all different strategies that you could apply to your assets. And of course, there's many others. But what you're trying to do is manage the asset consumption process. And then obviously preventative maintenance. This is where your preventative maintenance program should be driven from. Okay, so you want to look at what inspections, adjustments, lubrication, cleaning, parts replacement, spare parts strategy. That should all be directly in line with your risks. Even your work order prioritization. I work with organizations where we do that type of risk scoring, use the consequence of failure, bring it over to the work order, and use that to drive what work should be done on a day-to-day basis. But the other thing that should drive is your capital expenditures. Okay, so this is where your management strategies are made up of maintenance, renewing, operations, disposal, energy costs, all those components that you could forecast. Your preventative maintenance programs are driven that way. Your computerized maintenance management systems are configured to actually support all of this, track it, forecast it, and you can report it out. This is actually a real simple computerized maintenance management program that I've set up for a couple very small municipalities in New York State. I'm talking 1,000 people or less in a village. And this is a $1,000 software package that helps them manage all the assets that the village or town owns and the work that should be done to keep the risks in check. Okay? So it could be simple, or it could be something more complex like SAP or Maximo, but those systems should be configured completely in line with what your asset management program is. And of course, the detailed work order with the procedures, these are all should be prioritized with that risk-based approach. And then the other big piece of this is, can you forecast your capital expenditures? So if you know that there's a certain line at your plant and 50% of the assets are going to reach the end of their useful life 6 or 7 years from now, you could forecast out the capital requirements to do that. You could look at what an acceptable level of risk is and then make recommendations for where that capital expenditure should be applied for renewing assets, replacing assets, overhauling assets. And again, we've done some simple models for some small utilities, and they actually run their annual budgets based on these models. So what it does is the assets tell them what money should be spent. They actually set their budgets. Long-term forecasting, 20, 25 years out. of where they're going to need money, and they put it away. So here's the cost, expenditures. We have equipment replacements forecasted out. We actually often forecast out 100 years, which sounds ridiculous. But what we try to do is we look at the entire inventory of the assets. And in the water, wastewater world, we have a lot of buried assets, which might have a life of 80 years or 100 years. And we try to capture an entire life cycle of every asset we have in inventory so that we can see the replacement cost. And oftentimes that's 100 years out in the water, wastewater world. And then you could look at any particular year, see what the predicted capital costs are to replace or rehabilitate certain assets. And again, it's all transparent, so there's not smoke and mirrors with this data. It's justifiable, and it makes decision-making very defensible. So we've set our strategy, and we come to the fifth question. So I'm not going to ask you, because you guys are doing a good job taking notes. The first question, what assets do we own? What condition are they in? How much life do they have remaining? The second question, what levels of service are we trying to provide? What's our organization mission statement? Why does this organization exist? Our third question is lining up our assets with that mission statement to determine which ones are critical to sustain performance. And the fourth one, which is the big one, is what's the best management strategy to apply to that asset inventory? Fifth question, what's the long-term funding strategy? Where are we going to get the money to implement that plan that we came up with number 4? And you know, in the utility world, that's a lot to do with rate setting. Okay, so we're not just setting electric rates or sewer rates so that we could cover the O&M costs this year. We're looking at setting rates so that we can sustainably provide those services to the residents of that community without major rate jumps. So we're looking at what the capital improvements are long-term, replacing the assets, maximizing the value of assets. We're looking a lot at life cycle costs. We're driving this to set the rates appropriately so we don't have these rate jumps where they double or triple in any typical year, but they generally do increase over time. And then we're coming up with a plan. So we have our inventory of assets, we understand condition, life cycle costs, we do some alternatives as to how we reduce risk or manage risk, and then we come up with our financial plan. So really, asset management, if we were to think about it, isn't really one thing. It's really a lot of things. It's that box full of stuff. And that box has data and knowledge. There's people issues, as Terry talked about, the human resources. We have information systems that are managing the data, life cycle processes, organizational issues, and we're coming up with a strategic plan to provide sustainable products or sustainable services. So it's really, some people call it a 10-step process. So this is one way to look at it. So the first question is, what's the current state of my assets? So do you have an asset inventory? Do you know the performance of your assets? Do you know how much life? Oh, and the other thing is, do you understand the failure modes of your assets? So are the assets going to failure because they don't have capacity? Or are they going to failure because they're not providing quality that you desire? What's your residual life of those assets? What are the life cycle costs? Then you have to set your levels of service, your organization mission statement. Then you have to look at what's your best O&M and CIP strategies to align your assets with that. And then you have to look at where's the money going to come from to do it, long-term forecast, and we're just not looking at next year. We're looking multiple years out where assets need to be replaced or rehabilitated. And we have all this documented in a way that we can defend it, and it's transparent, and we could justify it. So it's really taking data and turning it into information, and then knowledge and wisdom. And that's it, the 5 core questions of asset management.
Great. A hand for Tim, please.